We're going to go about codes, requirements, and options for earthquake retrofitting. And I have with us Alex Rude, the owner and primary engineer of Pivot Engineering, who is our structural engineer. All right. There are two different kinds of codes that govern earthquake retrofitting in California. One is the historical building code, which we fall under, but there's also the California building code, which we can opt to upgrade our earthquake retrofitting options to incorporate some of that for the first floor, and only for the first floor and crawl space. We won't be talking about, we will talk about generally about what we can do for the second floor, but our options are limited there. So just wanted to give you that overview. And you'll hear us speak in some shorthand. So the CHBC, the California Historic Building Code, and the California Building Code as it deals with earthquake retrofitting. Who I don't see on the video, and he may not be here, is our project manager, Stephen Podesta, was going to be on Zoom. No, so we don't see him yet. He may have some input if he joins us later in some of that. The next bullet point is what we're required to do. So now this is where I'm really going to need Alex's help. By California rules, we have opted to make some improvements that are baked in. We're going to do what we will call option A, regardless of what the vote is here. Option A will be covered, which is bolting the frame. This is a wood framed building, which generally do well in earthquakes, but this is a solid redwood framed building, and bolt it completely to the concrete foundation. When we opened up the walls here and did the test, we did find out there are some bolts. In 1909, they did bolt to the foundation, but not to current code. So the bolts are too spread apart, and we have no way of knowing how deep they go because there are no blueprints or records. And they also do not have a plate on the top of them, which helps anchor the whole bolt and the wood together. So we are going to put in all new bolts. The other part in that is we are going to put in shear walls in certain areas of the building to help stabilize the building from shifting. And shear walls, as Alex has so well educated me to, also helps specifically when you have window openings, because the window openings and the door openings weaken the building, right? So on this floor alone, you'll see we have 3 windows, and we have 3 windows on this side that you can't see, but they're matching. So just in this room alone, there are 6 openings plus all the door openings. And so how do you stabilize the building with all that going on, right? And everything else that rests above us. So we are required, and we are going to do that minimum that I just spoke about. But other than that, there is nothing that California is requiring us to do for earthquake retrofitting. So all the options we're going to discuss with you are just that, options that we can choose to do for safety and for long-term viability of the building. All right. Have I misspoken in any of that? Okay, he has permission to stop me if I do. Okay, all right. So that's where we are. And then the last bullet point I want to touch on here is the options we have to go beyond are going to talk in 2 general categories. It's about how we secure the front of the building, which has the most openings. It has 2 big doors. It has huge windows, 4 huge windows. So there's 6 major openings on the front facade alone. And we're going to put in an elevator in that space too. And all of those options. So we're going to look at that, and we're going to also look at underpinnings for the current foundation, which would help prevent the building from tipping. The bolts, as we discussed, prevent the building from sliding off the foundation, which was a huge problem at the last earthquakes, that buildings that aren't properly bolted to their foundations just literally slide off. And so that's what we want to make sure that doesn't happen, right? After we've done all this work here. All right, next slide. All right, so the current plans roughly, and I'm saying roughly, fall into California Historic Building Code. It meets California Historic Building Code, which is 75% of the building code, except for the front facade. We don't meet it there. Yes, and now Alex, if you need to use the microphone so people can hear you.
Well, yeah, just to be clear, can you hear me? That work?
Yes, that works. You can lift that, squeeze that handle below you, and the whole thing lifts up. Squeeze that. Yeah, squeeze. Yeah, there you go. Okay.
Well, I would say the current plans, some of it meets the historic building code, the bolts for sure. But the walls, not all the walls meet it.
Okay.
So that means about 75% approximately.
Right.
can
California
say.
Building Code, a historic building code means that you have to do 75% of the work that, correct?
Well, no, yeah, what I'm saying is to meet the California Historic Building Code, so it's going to look confusing because that is 75% of the standard code loads.
Mm-hmm.
The walls in the current plan, those are approximately 75% of that.
Okay.
So they're a little below.
They're a little below.
Meeting the full historic for the walls themselves, but the bolting does.
Okay, great.
So there's a little nuance.
And one of the things I just learned in a meeting last week with Susie was that she wants to opt, and here we get into the weeds, opt for the sheet metal shear walls,
The braces, yeah.
the braces for all of it down here, because it actually makes the how it interfaces with the lath and plaster
Okay,
easier.
okay.
So that when we get to that, we'll explain the difference between the different types
Sure.
of shear walls.
Yeah. Yeah. And
Welcome to my weeds.
can I just say real quick, Ken has done a remarkable job at understanding this.
Okay,
I'm very
thank you.
impressed because it's complicated stuff. So yeah, kudos.
Thank you. Thank you.
Yeah,
Okay.
I can imagine.
So when I was buying my house up in Marin, and I sat down with the structural engineer to go over the review before, and the real estate agent thought he was going to have to walk me through it. We sat down and I started asking questions, and because of all the work that Alex and I have done together already, he was like, the real estate agent went, "Okay, I don't need to add anything here."
Yeah.
I was like, yeah, that I got. So the middle option that we're going to look at these. So to give you some options, we're looking at these three options. You get to decide. If you're a voting member here, you get to decide which option we're going to do. And we want to educate you on the three options. The current plans, the middle option is we do some more that brings us closer to the California Building Code. And then the option C would be to do the entire first floor at 100% of the California Building Code. And again, and I'm going to let Alex say this, this only covers the first floor, and it doesn't mean the building is earthquake proof. Can you say more about that, Alex?
Yeah, that's a really good point. Yeah, so the California Building Code, right? That's the one that a new building would be built to. That is the earthquake. It's designed to resist, and I'll get into that, what that means, is about the level of a 1906 earthquake. So if you can kind of imagine what that is, because there are many kinds of earthquakes, sizes and durations, all this, right? Intensities. So that's what that means roughly. We are due for something similar to that. So that's, should be clear. And the code, if the building meets that code, the intention of the building code is not that it guarantees that the building will withstand that earthquake, saying it has a high likelihood of that. So, and there may be significant damage, even to the point where maybe you have to tear the whole building down, and it still meets the code. So I know that seems strange, but that's the way it's written.
Right. And Alex explained it to me this way. The building code is designed to save lives, not buildings.
Right. Yes.
Right.
Exactly right.
Right?
Yes.
And oh, good. That's what the building
Yeah.
code is designed to do, is to save lives. And so that's an important distinction.
That's right.
That doing this doesn't mean that the building won't be damaged beyond repair. It just means that we're making it a safer place to be. Okay. And increases the likelihood that it could survive some kind
Yes.
of earthquake.
That's right. Absolutely.
Okay, great, great. Thank you. So I want to just to be clear about all the earthquake retrofits we're talking about are only for the first floor. Because of the structure of the building and the way it's laid out, there isn't much we can do without major changes to the second floor. And so we're not going to even venture there, okay? But the second floor rests on this foundation, the first floor, okay? All right, next slide. Yes.
If I could say something to that too, maybe be helpful. The first floor is, there's the most risk in the first floor for sure. So that's where most buildings fail in earthquakes is the first floor. The second floor, it's pretty rare and happen, but it's quite rare. So if you've dealt with the first floor successfully, you've mitigated most of the risk.
Great. So this is a drawing that Alex and his team have prepared for us. This is the first floor layout of the building. These dotted lines are shear walls, the dark dotted lines, where we'd be putting them in. These horizontal stripe lines that are hand-drawn, you see, these are underpinnings that would go underneath the current foundation and be bolted all the way through, drilled through the current foundation into the foundation that would lie below it. And I'm gonna have Alex explain what that does and why we may want to do that. This is, I'm gonna give you the map of the full CBD, the CBC, which is California Building Code. And so, and then along here where the elevator would go, this is Page Street, this is the front, this is the downstairs door, this is the middle door, and this will be the new lobby. This is where the elevator will go, right behind where Alex is currently seated. And what he's proposing here is that we pour two sister foundations that run alongside the current foundation to help reinforce it and to strengthen it. And I believe, and I wasn't clear from our discussions in this drawing, that we also then are bolting to those foundations.
That's right, yes.
That's right, we're bolting to those as well.
Yes.
All right, and so that is the full mix. And then also adding into the shear walls where we're putting shear walls, there's another drawing that's not here where we add in some support and some reinforcement in some of these walls, a wall that will run right where I'm currently sitting, that will help give more support to the second floor as well. And yes, so then the shear walls. So you see where the shear walls would go in here. This is all bathrooms is what's being made. And some of this would be reinforced with more shear walls. And then the next slide is the underpinnings. So I'll let Alex talk about the underpinnings.
The underpinnings are mostly there to, well, so just so it is clear, the walls that are bracing the building, they can fail in basically three ways. One is sliding, they just literally slide along. Because the earthquake is, what it's doing is it's trying to push the building back and forth. It's vibrating the building back and forth. So it can slide. It can slide off the foundation and come down. The other way it can, the other mode of failure, we call it, is racking, we call it. So it's when the walls just do this, just collapse this way. So they're just kind of creating a parallelogram and coming down. The third way is they overturn, they tip up like that. So they'll tip up, and then once they break all the connections from this tipping up, they're much more likely to slide or fail in some other way. So it's important to keep them tied down. So that's what the foundations are there for. Yes. Oh, yeah. Yeah. Okay, sorry. So these are, there's a plan on the left is the plan. That's a plan. And then the right is a plan. And that's a little section cut through the foundation. Yeah. That's, I believe, along this long.
Yes, so this is
here.
the west side of the building, and this is a section of the east side of the building.
Yes, a plan view.
I sectioned the drawing so we could see it more clearly in this.
Okay, so what that, is this on?
If we go back to the first drawing, Ryan, if we go back to the first slide, you can
Yeah.
see it in its totality. Okay. Yeah, so this is the wholeness of that. So this is the same drawing. This was what that blow up was, and this was this corner. And then I took a section of this corner to show. So that's what you're seeing in that blow up and that's the whole thing. So you see where he's talking about putting the underpinnings is strategically. And the reason for this is we have vents in the foundation that vent the crawl space, that allow air to come up from the crawl space, so this crawl space doesn't get too damp, or if it does get damp, it has a way of drying out. And we can't put these underpinnings anywhere close that would risk damaging those vents and then crumbling the foundation further. Is that correct?
That's correct, yes.
Okay. So that's why they're strategically otherwise placed.
That's right.
Right.
I'll run through real quick again, just with the mic for the people on Zoom. Shear walls, bracing walls, or any seismic element that's bracing. Well, let's call it shear walls now, which are generally plywood, but we can do some out of steel as well. They can fail in three ways. One is sliding. It just slides along. The other one is racking, so it's turning into a parallelogram, and then the story comes down. The third way is it tips up and overturns. It just tips up and overturns, which then the wall just starts tearing itself apart because the building's going back and forth very quickly. So that's what the foundations are mostly there to do, is to prevent the overturning.
Okay, great. Did I answer your question? Great, Susan, and now Rain has a question.
Yeah, my question's more about how do you take into account your neighbors? Like, we can be all sound and fit, but if their buildings slide, like, is that ever an issue?
It can be. I don't believe we're right next to neighbors, like real close anywhere, but it could be that they could fall onto your building.
Yeah. This one actually just went through an entire earthquake retrofitting.
Okay, great.
So they redid their whole basement in the last
Yeah,
few years.
that's a good question.
And so this one I don't know about, but yeah. Right. So the shear walls prevent those tippings in some ways. The underpinnings help prevent it from tipping completely over. Lateral moves, and the shear walls strengthen all of the openings. Next one, underpinnings. So the underpinnings involve having to open up the floor or from outside and to build these big concrete reinforced blocks, which have a bolt built into them. It drills through the current foundation, which bolts to the frame. And then in case of an earthquake, it would help secure that. And then the next slide is the diaphragms. So we have a unique building here, is that there's two floors. So there's the floor that you're looking at right below us, which is the ceiling here is also a floor. And then above that, in the sanctuary, we have a diagonal placed floor. It's diagonal slats, which was good. It keeps the building from shifting, like doing the twist, right? And that second floor also gives us the slope we have up in the sanctuary. That has to be leveled when we level the sanctuary to a solid floor. But the engineers have weighed it all. They know how much it all weighs, what we're going to add weighs, so that it adjusts the whole weight of the building for these stress loads. The second part of that is, though, keeping your building from doing the twist. This might be something with all the openings in the front, something that Alex is suggesting, and I'll let you speak about diaphragms.
Yeah, so diaphragms, it just means a plate, effectively, like a horizontal plate. So the floor and the roof act as plates because it's all tied together. So it's acting as one thing, like Ken said, helping it from twist and then transferring seismic loads throughout the building. And so because in the front we have the stair openings and then
there's the opening and this opening and two windows.
And then the elevator, and the elevator creates an opening. So we have to strengthen the floor a bit in where that blue shading is.
That's true, because when we cut this out, we are cutting out some of the flooring and some of the structure that runs across the building, right?
Right.
Yes. So in microphone, Marty, for the people on Zoom, and was that your hand, Anisha? No.
Well, I can talk loud.
No, speak into the microphone. It's for the people on Zoom. You can speak as loud as you want, and they still can't hear you.
Okay. Yes, thank you. It's going to be some time before this is complete. And I'm not sure what part of the presentation, but I would like to hear what do we do now
Hmm.
if there's a quake? Where do we go? What part of the building is more secure if it happens while we're here before we're retrofitted?
Okay, so we can talk about that emergency procedures, but the quickest answer is out to the street. So any of the, like if we were to right now, either exit right out front to the street. If those are blocked for any reason, we have an exit right there, which can take us out to the back alley or back around this way. Okay.
And what about arches like this one here? Is that-
Arches are actually, as I understand it, fairly secure. You want to go through them, but you don't want to stay in the building. You want to
Okay.
get out into an open space in the street.
That's right.
Okay.
Yes.
Thank
agreed.
you.
We've had earthquake preparedness drills before. Yeah, right? It, like an arch may give you a second of concrete, but the arch can fail and the arch can hurt you itself, right? It can
Right,
follow
that's
you.
right.
It's quite heavy. Yeah, it's carrying a lot of load. Yeah.
Mhm, mhm.
So diaphragms, and then the last thing I want to talk about is a sister foundation. So this is, again, this is Page Street. These are our two main doors. This is what we're cutting through the two floors to make the elevator come in. And we have to pour some kind of foundation for this. It's a lift. It's not actually an elevator. It's a lift because it only goes one floor. We don't have to put in a full operative elevator. We're doing a lift, but we still have to do some kind of work right here. So to pour this foundation would help secure that and give us a much more solid footing for those walls and for the front of the building. Next slide also shows another thing. I think one more slide in there, Ryan. Yes. So here's a frontal view of that. This is the front of the building. This is the elevator. This is the sister foundation we were just talking about. There is a beam, we're sure, when we open up the building, we'll find out, that runs the whole length of the building. And what we need to find out, because we can't see it right now, is if it's continuous. Contiguous? Anyway, it's one solid beam that it's not going to splinter into pieces, or if how it's bolted together. They may have built it with one giant redwood beam. The beams we discovered when we were doing some of the other stuff were massive, massive, massive redwood beams. So we don't know what we're going to find, but Alex has a plan here for us to strengthen and to reinforce that, to keep the building solid. And then also, Alex, why don't you talk about these blue plates in that section?
Yeah, so the blue plates are, well, there's several types of these bracing elements that are very strong. They're small, they're 24 inches wide. We have 6 of them right next to each other. So it's actually fairly inexpensive way to put a lot of strength into a building locally. So there's several companies that do this. There's actually one now out that's solid wood. It's actually really good too. But the ones we specified there are steel. They're like light gauge steel plate. They have bolts, big bolts, 1.8" diameter bolts that go down like 3-4 feet into the concrete. So it's a really good way. Yeah, it's an inexpensive way to brace a building as opposed to having a welded steel frame. Those are great, but they're expensive. So this is a lot less expensive.
And it's a great way to retrofit a building.
It's a great way to retrofit a building. Yeah. Yeah.
Okay. Right. So those are, and here's another example again of the underpinnings. Let's talk turkey. Right. So the next slide, I believe, will be the 3 options with their pricing tags attached. All right. So option A, the current plans, partial historic building code, we estimate is going to come in around $110,000. And that is for doing the bolting to the foundation and some shear walls only. That also doesn't cover having, if we have to move any electrics or any other things that are involved with that. Depends on what we're doing at the time when we're doing this, if there's some other costs involved. And the cost of restoring the walls isn't covered in that either, because we're planning on doing this with the full renovation. So we will be restoring the walls anyway. So that's going to be phased into another part. But this is the cost for the actual work. Drilling new holes, cementing them in, bolting them in. We have to be creative about how we do some of them and how we get to them, right?
Yes.
Yeah, it's complicated. On this side, the foundation is above ground. On that side, it's below ground. So it's different all over the place. The second, the middle option, which is some CBC, California Building Code. And what that generally entails, how they've broken this out, is that would be all of option A, plus doing the sister foundation and the panels that Alex just discussed on the front. And the diaphragms, I believe, are also included in that, and the beam across. So most of the stuff that we talked about for the front of the building, but what it doesn't include is the underpinning foundations that ring the perimeter
Right.
of the whole foundation. And then the final one, option C, is the full extent first floor. So the middle option was 160K. And then the full floor, to do the first floor with everything we've just described, would be approximately, and this is a good guesstimate, depending on when we do it and what inflation does, 220K. And the reason we bring this to your attention is that it is entirely likely that that may mean we need to cut something else. Right now we had looked at doing this level and barely squeaking in to get everything we need to do in budget. And prices keep rising and keep shifting, and I'm constantly trying to say, well, what can we do without? Where can we shift? How we can make this? What can we put off till later? What we choose at this moment is going to have consequences down the road. What those fully are, can't tell you right now, but we just need to let you know that there is not an unlimited amount of money, that this choice has to be made as mindfully as we can. Unless there is an unlimited amount of money that somebody wants to raise their hand for. Okay, no, Frank, that wasn't you. A microphone for Frank, please. He raised his hand right as I was talking about cash, Alex.
Okay.
So I wondered if we knew how each one of these gradations would bring down insurance costs. Have we kind of checked that yet?
Yeah, we're in the process, and I'm talking to our insurance company about two things. But first, right now we're up for renewal, upping the coverage we have on the building for normal fire insurance, because we've done massive improvements to the building. And I want to make sure that we really do have a fire replacement coverage right now. Originally, I think they had done the building for $330,000, which I think is grossly inadequate for this building, right? But that's what they told us the value was for fire replacement. So I want it to be appraised and re-estimated and get our insurance in line with what I think it needs to be. The second is we can explore, and we will explore, what earthquake insurance would look like for us in any of these options if it makes earthquake insurance possible, and what the earthquake insurance would cost us. Because in a difference of $100,000, if we can get earthquake insurance for $10,000 a year or $15,000 a year, that buys us certain numbers of a year at full replacement value. Because as we talked about too, we could spend this $220K and save lives, which is very important, but it doesn't guarantee that we will save the building, right? So it may make a long-term strategy of having insurance and having to carry it long-term. We have to make a commitment to do that. You can't buy earthquake insurance and then say, well, we didn't have an earthquake last year, let's drop it now, right? That's not the way it works. So those are options, Frank. It's a great question. And before the annual meeting, I'll have the answers for you, but I don't have them today. But it is something I'm thinking about and working on. One more for Susan. And if anyone online has a question, please raise your hand or raise the little, put the electronic one up so that we can go to you. Susan.
Okay, it might be helpful for the annual meeting to give an example of what we would be giving up if we went above the 110,000 for each option.
Well, the first one and the easiest one is the kitchen. The kitchen is budgeted at about $100,000 to $150,000 right now to do the upgrades to the kitchen. And let me explain why. Because you're going, wait, I can do my home kitchen for $40,000. Why is this kitchen going to cost us $100,000? Well, because it is a commercial kitchen. We are a commercial building. and commercial codes are much more extensive than your home codes are. So we have to have fire repressant equipment in there, and we have to have certain electricities, and then ADA. Once we start this renovation, ADA requirements, and we go over $175,000 in renovation, full ADA is required for us to do, which means we have to have ADA compliant counters, ADA compliant appliances, and ADA compliant sinks. And all of those cost more and are more expensive to install. So that's why the kitchen is coming in at that level. And what we're asking we have consultants, ADA consultants, and we have historical consultants, and we have permitting consultants and structural consultants. And I'm getting acquainted with all of them. And what we're trying to find out is if we get to that point, can we just say, okay, we're not doing the kitchen and wall it off and make it exempt from the permit inspectors who are going to come in and say you're not in compliance and you're not allowed to occupy the building until you get it into compliance. And we have to know that before we say, okay, we're just not going to do the kitchen. They may make us. We don't know yet, but we're trying to find out the answers to all of that. Okay. Welcome to my world. Elaine's shaking her head. Okay. Any questions from people online? Have we bored you or scared you to death? Kate, you're muted, sweetheart. Okay,
Whoop.
there
Okay,
you are.
if we went ahead with everything, including the kitchen that we've been planning for, and then we're still, and then we look at the options for the retrofitting, and we went with the highest one, we don't have the money. Do we have thoughts about how we would pay for it? Would we take out a loan? Would we do, or would we just not do it because we can't afford it?
That's a question for the community to answer. My answer would be no, we stop.
Okay,
We stop because to take on debt, as you know, as we're talking in our finances, I'm looking not at Kate because the camera's there. So everybody in the room, I'm looking over you. For everybody in the room, you know that where we are financially is we're making or not making our operating expenses.
Right.
We're not going to make our operating expenses. We're tapping into savings to cover those. So to take on debt would further crimp that
right,
on a
right.
monthly basis for how we would operate. And then we'd have to make cuts in what we offer, staffing wise, Sunday wise, all of that would grossly affect that. And so I would caution us not to
Okay.
take on debt, but to be very wise about the choices we make in the renovation. Make sense?
Yep, don't like debt.
Yeah, neither do I. Neither do I. Cash. We pay for it in cash. Hi, Connie. Welcome. Great to see you. And Jesse. Okay. Any other questions from online or in the room?
I have a question.
Yeah. So
It might have already been answered. It's hard to follow. But is there any, do making the choice now preclude, like, is some of the initial work of one of the choices going to still be accessible to do, or does it have to be completed and then the deeper work would not be possible? Do you understand my question?
it is always possible to do after, but it's going to be more costly to do after, and it will be more disruptive to the building. The last thing we want to do is to finish the building and put all the new fine stuff in and then decide 2 years later that we're going to add earthquake retrofitting to it and have to rip it all out and do it again. So it would cost you twice as much to do. So this is our opportunity to do it.
There aren't partial options that can be sequenced into the initial work.
Well, that's why we're giving you the partial. We're giving you the partial options that we can choose to do right now. It will not be possible or cost effective to say year or 5 years after we finish this renovation to go back and do it.
Yeah.
It will cost 3 times what it's going to cost us right now to do it. Just because we would have to rip up all the work we just did. Right?
That's,
And some of the stuff can be done from the exterior, but very limited amounts of it can be done from the exterior. We really need to open up these floors and get to and open up the walls down here and get to the stuff. And we're going to have one chance to do that. Connie, was it Connie? Who's Kate? Okay. Kate, you're muted again.
So the retrofitting comes first before all other renovations. And we have to decide which level. What will how will that entail our Sunday services? Will we have to not have them in person?
That's another discussion that we will include you in at that point. We haven't picked a general contractor yet. And so once we pick a general contractor, we will enter in discussions with the general contractor about whether we need to move out of the building, which is a scary prospect for me because then the contractors own the building and God knows when we'll get it back. Second, that's
Sorry
just
to bring it up.
on it, right? Is the other option is that we could do it, and we talked to two contractors about this already, that were willing to stage it, to do it one floor at a time. And that does cost more because they don't have the whole building. So we will have a full discussion with the general contractor once we pick them about those two options, what those entail, what that would cost us. And then we also need to do a cost analysis of what moving out would cost us, or what rental would look like then, what services would look like. And frankly, I want to add to that equation too, the cost to the staff, because the staff will bear the brunt of that work. Because they will have to do church in a box or set up some everywhere every Sunday. They're the ones who will have to move all of this out of here and put it in storage. And so either we hire people to do that or the staff, and I'm really concerned about staff attrition in that kind of situation and stress. The staff does a remarkable job. You saw them today, everything they pulled off. In the midst of COVID, they have kept us going nonstop for 2 years now. So they're remarkable. And I am concerned about adding one more thing to the staff's level. So, and the good news is too, is I should say this out loud. I've not said it. I've said it to small groups. I've not said it to a whole big group here. We're talking about a year from now, starting at the earliest, a year from now. By the time we pick a contractor, March, April, May, June, pick a contractor, you guys vote and we decide on a contractor, the board decides on a contractor, then we need to get on their schedule, the contractor's schedule. And with the supply chain issues, is this the best year to do construction? Probably not. We have no idea what next year will be like. It may be worse, maybe better. But this year we know what it is. Hard, and just getting on anybody's schedule and doing that. So it may be, and then we have to think of our holidays. Would we start construction? If our contractor could start construction in November, would we? Right? Move out right before Christmas? So all those things will come into play and we'll keep in communication with it, but we have to make these decisions one at a time as we go forward. We are thinking far ahead, Kate. We are, the board and I are talking about this regularly, and we have a discussion about it every month. But we can't make the decision until the general contractor's picked, until all those things along the way. Susan, microphone.
So one thing about this, I know we're going to make it a decision, but once the general contractor comes on board, we'll have more of a more solid cost estimate. And we may find that, we want to make sure we don't start construction and we don't have the funds to complete it. So even though we would be voting in February, there might be alterations to that vote. Once we have a firm cost, a more realistic cost estimate?
Current, because the cost estimates we've been working on are now year and a half, 2 years old. Diane had her hand up.
Yeah, I was wondering, so we're doing this retrofitting before we're doing any other reconstruction. So how long?
No, that's actually not true. It'll be done simultaneously to the other construction. It will be part and parcel with the other construction, not in advance of it. We're making the decision now because we can't finish the drawings and get a realistic estimate for the general contractor until we know what the general contractor is going to have to do. So we need to make the decision about the scope of retrofitting so that we can finish the drawings, and rather than draw two different sets, which will cost us a lot of money to draw two different options. In this kind of detail, we're talking about architectural drawings are very expensive to produce. We want to have one set to produce when we know what we're going to do and present it to the general contractor so we get a realistic budget of what this is going to cost us. But we're not doing it before the work. We're just making the choice now for what the work is so that we can make the drawings to find out how much it will cost. I know this is complicated, but it's how this jigsaw puzzle gets put together. Right? And Brian and someone else had their hand up too. Sorry.
So really quick, for simplicity's sake, because I need all the simplicity I can get, on the retrofit options, A, B, and C,
Yes.
is there, you may already have this, so I may be jumping ahead, but
Go back
is
to
there
it.
A with the different elements, B with the different elements, and C with the different elements that can be disseminated so we can see all
Yes,
that?
I can write it out. I can tell it to you what it is if you share that screen right now. And correct me if I'm wrong, jump in. And so it's this
It's
one.
that one there.
Yeah. Hit that one. Not a touch screen. Yeah. Okay. So, great. So current plans are for bolting the frame to the foundation as it exists, and putting up shear walls, a limited number of shear walls. All right. So it's bolting and shear walls. Middle option B is bolting the foundation to the frame to the foundation, shear walls, adding some more shear walls, pouring a sister foundation out front, the diaphragms, and the hard panels in association with the elevator to help strengthen that, and the cross beam that goes across the whole front. And option C is all of that plus the underpinning foundations all around the perimeter of the building, which keeps the building from tipping over. Okay,
Yeah,
and I'll
yeah.
write that out and send it out. I'll do another slide before we send this deck and this recording out with those quantified under each option.
Thank you.
Okay,
And option C also includes more shear wall too, as well
That's
as the-
true,
the
correct.
underpinning, so.
yes, yes, much more shear wall in C. Right. Okay. Yes, Alan. And then I think, Laurie, you had your hand up? Right? Yes.
Yes, no, I'm listening again.
Okay. So Alan,
So I'm assuming that A, B, and C, each one would take longer. And I'm wondering, do we know how long? Like say A compared to C?
Alex, do you know the answer to that? I don't.
I don't. I'm sorry, I don't. Yeah.
That's a general
that's a good
contractor question. It's a great question, but yes, it is going to, it is more invasive. Yes. We're gonna dig up more, do more, pour more, take longer.
And
Yes.
so if we choose C, might C take more time than the
Yes.
contracting of the whole building, the retrofit or the,
Well, we can't
renovation of the
close up
building.
the walls and finish the first floor until C is complete.
so
Right.
if we have to be out of the building, that will take longer.
Correct.
Okay.
Right? And even if we have to, even for the time we're out of the first floor, it will take longer. Say we stage it and we keep the second floor and we give them the first floor to work, do all this work while we're just having Sunday services upstairs, right? Once a week. The C is going to take longer. They're going to need the first floor longer to do that.
That's right. Yeah, and
Absolutely.
I'd just like to say, it wouldn't be proportional to the cost increase. Does that make sense? So it would be, maybe 10, 15, 20% longer, something like that, but not 100%
Right.
longer.
Okay.
Does that make sense?
Yeah, when you say 10, 20%, what, how
Then
long would they take?
I don't know. We need to talk to the contractors. Great
And the other
question,
thing
but
about the
yeah.
contractors, yeah, and the other thing about the contractors, which we've said before, but it bears repeating, we're in an old building. They don't know what they're going to encounter until they open the walls.
Right.
Right?
That's right.
Right? There will be surprises. There will be surprises. We have no blueprints of the building as it was being constructed. We have as-built for what it looks like now, but those are done with the walls closed.
Right.
Right? So we know where the walls are. We don't know what's in them. Right? So
I guess,
that's that. Yes. Now, Laurie, did you want to have you have a question about that? And then Jesse? No, Laurie, you're good? Okay. Jesse?
I guess that was kind of my question. I mean, as you do, is it everything? I mean, most of the work as you would do it, you would see the work that is in the lesser options. You still have, it does include some of the foundation because you're bolting the foundation. The bolting is the first floor.
Yes, it all involves foundation work.
And at that point, you would probably be able to see a lot of the options that you're considering, the
Yeah.
options that would reveal more about the project. You would probably be able to see them in doing that work, or are there places where you
Yes,
expect?
but at that point, we are in full construction. So that won't be done in a silo. The first thing that'll happen will be the destruction. The contractors will come and they'll rip everything out and expose everything, and they'll haul it all off, and then we'll know. Before the bolting of the foundation happens, we'll be seeing behind the walls. So that's what's going to happen at that moment, right? The demolition crew comes in.
So that work has to be done regardless. So that's, I guess, on my
Correct.
question about the decision making. Is it not possible to move forward?
We can't, so again, I'll say, we can't move forward until we decide the level of retrofitting we're going to do, because we need to do the drawings so that the contractors can give us bids, so we understand what we can afford and what we can't afford. So we need to give to the contractors how much we want to do, so that the architects we need to decide this so the architects can draw it, and then the contractors can bid it, and we can pick a contractor. That's the order we have to go in. There's no option on how we do that. We
But
need
they
to
still might.
pick, we need to decide, we then draw it, and then we price it.
But they still might discover unknown things that they haven't drawn for.
They will. Absolutely. But the contractors will build some of that into their bid, and some of it they'll try and charge us more for. And that's why we have a project manager to say yes or no. And in the bids will also be overrun a cushion. Like in the last bids, we had a 20% overrun option. We expect things to cost more than they first tell us, and we build it into the bid.
And
Right?
Ken, if I
So-
could just jump in here for a second.
Yes,
Hi,
welcome, Deanne.
everybody. I'm hearing the question that Jesse seems to be asking underneath it, which is that, if we find stuff, can we adjust? And the answer to that is, of course. It's just that it's very, very expensive. So we can add change orders, and that's Stephen raising his hand here, but it raises the cost significantly if we're pivoting in the middle of something that we're not permitted necessarily to even do. So,
And also, yes, once they've done competitive biddings and we picked a contractor, we are now married to that contractor.
Right.
Married to them, right? And so what they say that it's going to cost, we can do, no, this isn't reasonable, and that's what Stephen's good at. This isn't what industry standard is, but we are over the barrel at that time, and every moment of that delays us getting the building back. Every change order delays us getting the building back. Right? Stephen. You're muted, Stephen. You're muted. We can't hear you.
I'd really like to help the community to understand that one of the things that I've one of the things that I've emphasized since the first day I came on board is to do the work to help eliminate surprises, because surprises cost money, surprises cause stress, and surprises cause delays. And so what Ken's being a little modest about here is that we have spent a lot of energy and money to explore certain parts of this building that were previously unknown. And so the idea with this old building that didn't come with any plans is that when I first got on board, there were a lot of unknowns, there was a lot of mystery, and there was a certain mindset that we were going to kind of figure it out as we went along. And so for me, to know that that's not healthy for people who are paying the bill, you know, I made it a point that I wanted to spend a little bit of money to find out what's really going on with this building. So we had some major issues about, you know, how strong was the concrete in this 110-year-old building, because some of it didn't look very good. What did the foundations really look like? How much decay was there? And so the potential for surprises with a project like this is very high, but we have not been necessarily spinning our wheels with the time that's been spent so far.
Well, are twiddling our thumbs, right, Stephen?
No, believe. And so a lot of things, and the idea that you, and Alex can certainly speak to this, how common is it that you start a project and then you come across something you didn't expect to come across, and then you have to stop and completely like replan the project. And so we've really tried to, as a team, we've tried to be proactive so that we can help to not have delays caused by surprises. And surprises are only surprises if you leave them alone and don't chase after them to begin with. So we know a lot more about this building than we knew at the beginning, and a lot more than most people would know, because as you probably have seen if you've been in the building, there's been a lot of opening up of different walls and exploring. And so we're much farther along with knowing this building than we were before.
Yeah,
I would second that.
Yeah.
And I think, and Stephen's done a great job of really pushing that, and it's been really helpful. So compared to most projects, there are way fewer unknowns now.
And
But
for
of
those
course
of you who
there
don't
could
know,
be-
Stephen is our project manager, so that's Stephen Podesta. And he's also being modest when he's the one who crawled when we opened up the pit over here, the baptismal pit, when we took that out. Remember that? Yeah.
Oh,
And
yeah.
Stephen's the one who crawled under in the crawl space on his hands and knees just to examine the foundations all under here. So there's just a rough slab underneath this with minimal crawl space, some of which is very, very treacherous to get through. So
I mean,
that
you
was
really-
Stephen.
If I had to put my finger on it, I mean, I would say that we have reduced structural surprises at the lower level by 80% so far.
Yeah, agreed. Agreed.
You know, the kind of, I mean, I have been on so many projects where there isn't the effort to open things up beforehand, and Alex has certainly been there too. And construction starts, and then someone says, "Oh my God, look, there's this crumbly concrete. Let's go test it." And so everything comes to a screeching halt for two months, while all of this surprise gets investigated. So we've been proactive with the surprises, and so I think that the community should feel good about that. That when Ken's talking about certain delays and certain timelines for certain pieces and parts of the project, that we've eliminated a lot of those already. And moreover, yes, it is my job to haggle with contractors about prices, but there's a lot less haggling that's necessary, which means you don't have to pay me to haggle when you know what you're dealing with originally, and you can plan for it as it is instead of as you hope it will be.
Thank
So
you.
in terms of options, can I ask one more question?
Sure.
Based on then in terms of option C, where you're talking about the underpinnings and the lower level foundation, is that correct?
That underpinning,
Primarily,
the underpinnings are option C. That's the plus the sister foundation is in option B. But the underpinnings are the major additive plus more shear walls in option C.
And so those things you do already have enough information about to proceed with the drawing.
Correct.
You know,
We
I'd like
know,
to actually.
we
if I
know
can-
what the foundation is now, right, Stephen? And we've tested one wall.
But if I can actually clarify that, in a really simple way, when the engineer does their calculations to see if the walls will overturn or not, the calculations reveal that there's a certain amount of force that the earthquake will generate at certain points. And so in order to resist those forces, bolts have to be epoxied in place. And so with option C, which is the full building code retrofit, the underpinnings are what's necessary to fully resist the overturning loads. And so we simply took option C and removed all the underpinnings from it, and we ended up then with a partial ability to resist the loads based on just epoxying into the existing foundations.
Okay, other questions? Yes, one more, Marty. Microphone.
I'm wondering about the shear wall options. I believe you said one would be, and I'm thinking that it could be plywood or metal, some form of metal.
Yeah.
I'm wondering the effectiveness and the protection between the two and the cost efficiency or the cost amount between the two.
Okay. Well, plywood does a great job. It's been proven to work very effectively, both in full-scale testing of buildings on giant shake tables and things. So there's a lot of confidence in that. That is the go-to. So we have sort of a hierarchy. We start off, can we get plywood shear walls to work? Because they're the least expensive. But like in the front, we don't have enough wall. We don't have just enough wall length. Yeah, because the windows and doors, exactly. So that kind of forces us into something else. And so then it goes into these steel panels or these, these prefabricated panels, seismic bracing panels. And so it's not, they're both effective. So it's not necessarily one is better than the other. That's a great question. But both of them are designed to handle code loads or some portion of code loads, if that makes sense. So it's both work equally well, I feel, if it's done properly, anchored properly to the foundation, et cetera. Am I answering that question?
Partially, and what about the expense ratio between the two?
Okay. Okay, so it's a tough thing to say. So for the given capacity, generally the plywood is going to be cheaper, maybe, I don't know, 25% cheaper for plywood.
That's all.
Yeah, exactly. They're not that expensive, these bracing panels. But like I said, in the front, you just don't have that option because there's just not enough wall.
And in a lot of this room, Susie, as I indicated, has told me she wants to use the sheet metal on gypsum
Yeah.
option because of how it will interface with
Right,
the lath and
right.
plaster that we're not removing.
Okay,
Right?
yeah, that's right. So there is an option to use. So instead of plywood, I'm kind of mixing up with the panels. So this is a material that's starting to be used more. It's not used very frequently now, but we do it on a fair number of projects in the last few years. So what they do is they take sheetrock, gypsum board, and laminate thin sheet metal to it. So one side has thin sheet metal. It's like 20 gauge sheet metal, which is, I don't know, less than a 16th of an inch, I believe, thick. It gets laminated and glued on there really well. Then that gets put onto so they take off the lath and plaster that's there or sheetrock, whatever's there. They pull that off. And then you take this laminated steel sheet metal wall and screw that into the studs. And that again performs very well. that is a little more expensive than the plywood for the material. Yeah, but just think of it interchangeable with plywood, really. But it has a huge benefit because then you don't have to change out all the casing around your window now. Now you've saved a ton of money because that's way more expensive.
Yeah.
To redo all your windows. Because you can just replace
Because
the
we're
lath
not
and
adding
plaster.
to the width of the wall.
Yeah.
With plywood, right? And the sheet metal has a greater strength than the plywood for thinner.
Yeah, it's
It's-
a little bit more, not a ton more.
Yeah, but compared to the width of a plywood.
Oh, yes.
so
Yes.
1/16 of an inch to 3/4 of an inch
Right.
or a half an inch, whatever the plywood is usually different in size, but the same strength.
You've done your homework.
Yeah,
Ken.
no,
You
he's
really
good.
have. Thank you.
Thanks. So, yeah. Anything else? Kate?
I have one more question. Oh, sorry.
Ken, so did you say the membership will be deciding which of these options at the membership meeting next month? Is that correct?
Correct, at the annual meeting.
Yeah.
So what we wanted to do was to get this information out and let you absorb it and let you do the research that it was impossible to present all this to you and ask you to vote on this today.
Right. Yeah.
We are also sending this video out with the PowerPoint deck to everyone who wants to watch it and put themselves to sleep at night. I highly recommend it for insomniacs. And that way, in the end of February 26th, we can have an informed vote about what to do with this. Also, like I mentioned to Frank, what I will do by then is hopefully have some more, or I will have more insurance information on what the options in an insurance realm look like.
Just one further point, Ken. Since we'll be voting on this at the membership meeting, will we, I mean, unless we take option A, we don't have the money to cover this. So will we know maybe if we axe the kitchen, how much that would save, or if we took out the elevator, how much that
In
would?
rough numbers, we can't take the elevator.
Okay.
Because it triggers the ADA requirements.
Okay.
Once we spend $175,000, we trigger full ADA requirements because we've asked this question. Trust me. Deanne and I have looked at it like this from every angle. And the code is that once we spend $175,000, which is blinking around here, right? That we have to do full mitigation of ADA compliance, which means, because we ask, can we leave the bathrooms where they are, not move the bathrooms? The answer is no. Answer is no, because we must make the bathrooms to be more accessible. Right now, you have to walk through the whole building to get to the bathrooms, and we need to have wheelchair accessible bathrooms, and we need to have 3 of them, according to code. And so they have to be torn out and moved. And so that's going to be triggered. The elevator then gets triggered with that. We can't opt not, once we start the renovation, we can't opt not to do the elevator because people with different abilities can't get to the 2nd floor.
So the kitchen is really the only thing that we can axe.
The kitchen, the finishes, the AV equipment, and things we do on the 2nd floor.
And will we have like, if we took those things out, which level then could we reach the 3rd level with that or not?
So the kitchen is, like I said, is approximately $100,000, probably with the current rates at $150,000. The AV equipment, we had originally budgeted AV upgrades at $100,000. Right now, Stephen's doing a great job of negotiating it down from $450,000 to $225,000. So it is coming in at twice what we expected. And we are looking at every line item in it, but some of it has to be done again. While we're doing this, it is the only time to build the infrastructure for things we want to do down the road.
Yeah.
So we want to put the pipes and the channels and the systems in so that we can actually buy the equipment and install it easily later without running wires all across the floor and down the walls and across the ceiling. We have to do that work when we do this renovation. So we have to be very mindful, and we are being very, very careful and thoughtful about everything we're saying yes to and what we're saying no to. but some of it is literally just the understructure that has to be built so that the building's ready for another 100 years. The reality is no one's done this for this building in over 100 years. Period. Right? And what we're taking on wonderfully, because we love this building, is we're trying to get it ready for its next 100 years. Right? That makes sense?
Yes, thank you.
Okay, Jesse.
Yeah, I was just wondering, because it's California code, probably all the materials and things are including climate, green, whatever, green building to make it more fuel efficient overall. Is that correct?
Actually, we're not triggered by any of that. And some of the things you would think that would happen with that are not. Let me answer it this way, Jesse. It's been an education, right? This building is not insulated, and we're not we're not going to insulate it.
You're not.
No, because to insulate it properly, we'd have to take all the siding off. Because what had happened is if we put insulation in this building right now, the siding is porous, and when it rains, water comes in. The building naturally dries itself right now. If we put insulation in, the insulation will just get soggy, and then we'll have a mold problem. If we were building this building from scratch, before we put the siding on it, we would waterproof it and we would insulate it. But we'd have to take all of the redwood siding, the old growth redwood siding, off of the building in order to insulate it. So we won't. Period. End of story. But what we are doing is we are getting heat pumps. So our air conditioning and heating system will be electric heat pumps. Currently, we can't get solar panels for a multitude of reasons, but I'm continuing to explore those options, and that world is shifting rapidly. So maybe down the line, we'll be able to put solar panels in the building on the roof somewhere. But right now, that's currently not an option. Okay, so we are, and there are things we will not be able to do here is the answer.
Because the interior walls aren't really changing when they do all that.
Some of them are, but it doesn't matter if the interior walls change or not. We can't put insulation in because the exterior walls will leak on them and ruin all the insulation and cause the mold problem will be worse than having a porous building. And right now in COVID, having a very porous building has been a blessing. Right? We have great ventilation. The building breathes well. I saw, is that Susan?
Yes. Yeah. So actually, and yeah, just thinking about that, because all of that siding would go to landfill.
Yeah. Yeah. We would be turning redwood siding into landfill. We're returning the carbon footprint of it would be, and replacing it would be.
And all of,
cost prohibitive.
Right.
Yeah. Not gonna happen.
I mean, the other thing I'm sure we're doing is doing low flow toilets. And sinks, having the faucets that are aerated. There's California Title 24 with lighting. I'm sure we're meeting all of those
We're
standards.
meeting all those standards, yes.
So there's lots of ways. I mean, I don't know. That we're being encouraged to go for like an electric kitchen, so electric stove instead of
We're doing all electric, yes.
So all electric. So that's.
I can't hear Susan.
Oh, I'm sorry.
I'm sorry.
Did anyone hear me on the?
Yep.
Okay. Sorry, Francine. You want to call me? We'll talk.
Yeah. So I'll reiterate it in my booming voice. Is that the air, the faucets, the toilets, the lighting is all current codes, current green codes. All that is all being replaced with all of that. The chandelier right now, it's all LED. Every light bulb we're putting in, even these lights right now, are LED compared to what was here before. So, and we're going to keep going towards the ultimate standards with that, all of that. But what you might think, like I said, for the insulation and other things like that, we can't do because of the age of the building.
Okay,
right?
thank
So
you.
there's other things we can do. Yeah. Stephen's hand is still up, or is that from before, Stephen? Okay, so I think that was from before. I think we've put everyone to sleep.
No, sorry, my hand's a new hand. So, sorry, I'm still a rookie at this. So Ken's comment about getting the building ready for the next 100 years you reminded me just to kind of want to give all of you a bit of an education real quick, which is that the last major earthquake in the Bay Area, the last true major earthquake in the Bay Area was the 1906 earthquake. And so when we talk about the next 100 years, this building hasn't been tested really by a major quake since it's been built. And so I'm not going to drag this on and complicate this right now by talking about all the different faults and the chances of those faults failing. But if you simply want to go do your own research about the likelihood of a major quake in the next, say, 30 years in the Bay Area, there's lots of information out there. And I would encourage you, each of you who's a stakeholder in this building, to make yourself educated about the chances of a major quake hitting this building.
And so everyone who here is a member of this community, you're an owner of this building. Congratulations. Your assessment will be. So I jest, and Deanne brought up a very interesting point. If we had stayed at Bush Street, we wouldn't even be thinking about this, which is not a good thing, right? Bush Street, our former home, had brick foundations. Yeah. We've got poured concrete, 100-year-old poured concrete, but we have poured concrete, and we have options, and we have money. It's just, this is part of the abundance, is we have to choose how to spend the money we have, right? That is part of prosperity. You have to choose. There's always more we could do. If I told Alex we had no limit, he could come up with lots of things to keep his company going for the next. How do we deal with that roof? Right? But we have to make a choice within our budget and within our prayerful contemplation of this. And that's why we're doing this early. Not early for our team who's been pushing me to do this, but early till we were ready to have this discussion. Aren't you glad I didn't give you this as a Christmas present? That's when it was originally scheduled for. We had to delay it, but yes, here it is, and this is what we get to think about and talk about. I am here to answer all your questions. If I can't answer them, I will send them to Alex, and Alex will give us written responses to them. He's accessible and here for us and helping us all make the right decision. And Stephen and Deanne have been part of this the whole time. So there's no lack of resources around here to help us make the decision, but we have to make it. Okay? Let's take this to prayer. Okay? So we give thanks for this infinite possibility of how we protect the people of this building. For the community is not the building, but the community is the people we bring together to raise each other up, to foster the ideas. Knowing that we have been blessed with this abundance, we now know that our mind is being seared right now with the absolute wisdom to make wise and purposeful decisions for the good of this community and for all. So we take this into our time of reflection, of meditation and discernment. And we know that every step along the way, we are supported and guided, for there is only one, and we are grateful to be part of it. Amen.
Amen. Ashe.
Ashe. Love you all. Thank you so much. I'm here for you. Write us your questions. We will send this out with the adaptions that I mentioned. And let's give a hand to Alex Rude for spending his Sunday afternoon with us, and to Stephen Podesta for doing the same. Thank you all. Thank you all for giving us your time. Appreciate it.
Thanks, everybody. Love you.
Thank you.